Hello, thank you so much for joining me today. My name is Stephen Camilletti, and I'm accompanied here today with my partner Daniel Lumley to talk about our heat exchanger design.
Our problem was to design a heat exchanger using Aspen Design that will assist in the cooling of high-performance computers here at MSU. Some of the parameters include the HPC continuously generates 1 megawatt of thermal energy. Roughly 44 kilograms per second of water flows out of the reservoir for cooling. The water leaves the reservoir at 57 degrees Fahrenheit and the heat dispersed cannot exceed 120 degrees.
One of the first parameters was the selection of the liquid. We chose propylene glycol that is made by Dow Chemical because it has a high boiling point and a low freezing point. It remains in liquid form from negative 59 degrees Celsius to 188 degrees Celsius. It is often formulated with corrosion inhibitors, and it has a very low toxicity, which limits the danger of it spilling into the potable water.
The next parameter was to design the heat exchanger. Our shell and tube exchanger was the AEU, which is a channel and removable cover, one pass shell, and U-tube bundle. One of the advantages is that the heat exchanger is able to withstand thermal shock. Another advantage is that the outside of the tubes can be cleaned because the bundle can be removed. Disadvantages include that the insides of the tubes cannot be cleaned effectively and that it is moderately expensive. A picture is shown on the bottom right of the slide.
Our tube layout pattern is a triangular 30 degree because it accommodates more tubes than a square pattern, and it has a high heat transfer coefficient. A picture is shown here on the right. We also used a single segmental baffle type because it supports the tube and enables a desirable velocity. We chose a horizontal baffle because it minimizes accumulation of deposits at the bottom of the shell.
Here is a summary of the results of our heat exchanger. The total heat load that it can handle is a little over 1 megawatt. The length is 10 feet. The pressure drop for the shell is 1.57 psi and 1.47 for the tube. The total price of the system is roughly $56,000. Three potential suppliers include Equipnet, Bell & Gossett, and API Heat Transfer.
This graph here represents that as the distance in the tube increases, the temperature of the cold stream does not increase by more than 3 degrees, and the temperature of the glycol propylene heats up to exactly 120 degrees at the end of the heat exchanger.
Does anyone have any questions?